This is an interesting study, just came out in Nature City. Basically, when people do flood defenses in cities, they tend to look at some metric that says how the intervention helped overall. But when you go into more details, it turns out that partial flood defenses can actually end up exacerbating certain things like inequities and also shift risks. So I'll read briefly the very detailed analysis. I'm going to show just one figure. It says partial flood defenses shift risks and amplify inequality in a core periphery city. So you have a core city with suburbia around where people come in and go out on a daily basis. This is a very common typology of cities. They offer lots of opportunities, but housing can be severely restricted, so people tend to live outside. It creates other problems, but let's not worry about that right now. Let's read the abstract and a few more words. Cities worldwide often rely on partial structural defenses to mitigate intensifying flood hazards. Although large-scale analysis suggests that partial levee coverage can reduce overall damage, its spatiotemporal effects remain understudied, particularly in cities of the global south. Using a hydrodynamic model forced by extreme discharges, so 100-year return period type flood events, along with depth damage curves and demographic data, we find that partial levee construction in Surat, India, which is in the state of Gujarat on western coast, lowers citywide flood losses by 31.24 billion rupees in core urban wards and by 10.34 billion rupees in suburban neighborhoods. However, both damage and exposure become more inequitable, with the Gini index rising by 20% for damage. So Gini index goes from 0 to 1, perfect equality versus maximum inequality. So 20% damage for damage is 0.55 to 0.66, and by about 26% for exposure, so 0.31 to 0.39. We introduced flood stripes and a protection-induced time shift to capture both spatial and temporal changes, finding that certain near-river wards can remain flood-free for up to 12 hours longer, whereas some downstream areas flood up to 7 hours earlier under partial levee coverage. These findings underscore the need for integrated strategies that address both dimensions of partial flood protection, ensuring that benefits for some do not escalate vulnerabilities for others. Okay, so we need to make sure that the benefits are counted, including all the stakeholders, and not just looking at some local scale where the immediate interventions have immediate benefits. Just to read some of the text, in this study we examined how partial levee coverage can fundamentally reshape citywide flood risk and socioeconomic vulnerability by comparing baseline, so no levee, and protected partial levee scenarios, employing fully coupled one and two-dimensional hydrodynamic simulations to capture spatial and temporal flood dynamics, assessing neighborhood or ward level economic losses, and finally analyzing inequality through Lorenz curves and the Gini index. So it's a detailed calculation. Although pluvial and tidal processes also influence local flooding, we focused on riverine flooding from the Tapi River as it remains the dominant driver of large-scale inundation. To move beyond conventional aggregate cost-benefit metrics, we introduced two methods that illustrate both the magnitude and timing of flood impacts. First, flood stripes track changes in flood extent and duration across each ward, revealing when and how severely an area transitions between dry and submerged in each scenario. Secondly, a protection-induced time shift pits metric quantifies whether partial levee coverage delays or accelerates the onset of flooding, indicating gains or losses in critical lead time. So the findings in Surat reveal that while levees can substantially lower total flood losses on the city scale, they often exacerbate uneven outcomes by diverting severe inundation toward peripheral wards. This approach holds broader relevance for other urban centers where cost-limited structural defenses drive adaptation efforts, underscoring the importance of multi-scale governance and equitable resilience strategies. Obviously, there is always an optimization, and maybe there are implicit biases in terms of protecting certain regions or neighborhoods based on various factors, let's say. But obviously, all impacted locations have to be taken into account. So this is Surat's map looking at population densities. You can see there is a very high density here, 8,001 to 180,525 per kilometer squared, and ward and village classification adjacent. They are far here and too far on the periphery. So you have core periphery kind of structure to this city, and then there are various other boundaries, and there is a river running right through it, which makes it ideal to study river flooding with the 1,000-year return period kind of event. And the levee is put in here, partial levee in this faint red line that you can see on this area here, and upstream and downstream points are noted. Here is the upstream and downstream. Okay, I think the Gulf of Kambat is here, if I'm not mistaken. Please look it up. Okay, water level and distance from upstream to downstream in kilometers. So upstream point here, there is a bridge here, the Kahol Bridge, Tapi River Bridge, and the another bridge down here. So levee protection stretch is over here that we looked at, and left bank, right bank, and protection level against a 100-year-old flood here. Okay, I'm being very stingy in the details, but here study area and the contrasting baseline and protected scenarios. City map we looked at already, and B, longitudinal river profile indicating left and right bank elevations. So you can see that. Okay, this is water level in meters. C is the spatial flood inundation map of a baseline scenario under a 100-year return period. You can see how extensive it is, with levels shown in meters, greater than 3 meters in the dark blue colors. The map for protected scenario here. So this is the full flooding protected scenarios. You can see the changes. E, map showing the net change in depth, baseline minus protected. Wards adjacent to the levee see lowered water levels in blue shading. Maps in A and C and E are from ESRI, etc., etc. Okay, so you can see negative numbers in this reddish colors and positive numbers in these bluish colors. So blue shading showed lowered water levels, and the details are as mentioned before. The peripheral regions can get earlier flooding. Very brief, but I just wanted to give you a message that when you do urban flood interventions, trying to solve waterlogging and other problems, the extent of the influence has to be considered, not just in terms of physical water logging, but also other details as to which stakeholders are affected in which way, positive and negative. So reading some discussion, although global scale assessment can quantify the aggregate benefits of flood protection in urban regions, they often overlook how partial or piecemeal embankments can redistribute hazards within a city at finer scale. In Surat, India, a coastal river city exhibits a pronounced core periphery pattern. We addressed this gap by introducing 2 new analytical approaches, flood stripes and the pits, to capture both the spatial and temporal aspects of constrained flood adaptation. Our findings indicate that partial levee coverage substantially reduces flood depth and economic losses within densely populated wards, yet intensifies floods and accelerates the onset of floods in peripheral neighborhoods. This outcome underscores the paradox of constrained adaptation in rapidly expanding cities. Basically, every time you have to do adaptation, even if you plan for 100-year flood events, there will be many constraints, financial being the top one, and we're talking about going beyond crisis management into building resilience. So it's very easy to focus on the region that is heavily flooded and not consider the regions that are further away but are going to be negatively affected by protecting one region. By quantifying when wards begin to submerge and how much non-submerged area is gained or lost, flood stripes and pits together illustrate how hazard redistribution unfolds over time, and these results highlight the need for multi-scalar governance that not only accounts for aggregate risk reduction but also ensures equitable outcomes for downstream or less defended neighborhoods. Despite these caveats, our method, so they have some details on how the method is not comprehensive, has some caveats. So despite these caveats, our methodology and findings resonate beyond Surat. Many coastal and river cities across Asia, Africa, and Latin America are similarly reliant on partial embankments or cost-limited structural defenses, often protecting dense municipal cores while leaving peripheral zones frequently characterized by weaker governance, lower investment, and higher social vulnerability at greater risks, can be often informal housings or slums as we call them. By coupling hydrodynamic modeling with inequality metrics and a timing-based framework, we offer a transferable diagnostic tool to assess which areas bear redirected floodwaters and how quickly hazards can escalate. Such insights can guide urban planners in balancing infrastructure investments between the core and the periphery, aligning protective measures with land use policies that prevent further encroachment into high-risk floodplains. In parallel, decision makers could mobilize community-level flood preparedness initiatives, ensure better emergency response capacity downstream, and adopt adaptive governance approaches that continually review levee alignments or embankment heights as conditions evolve. Ultimately, if policymakers wish to genuinely reduce rather than merely relocate the flood hazards, recognizing that partial solutions can yield safer cores but more exposed peripheries is crucial. A holistic and iterative approach to resilience that includes physical defenses and land use regulations and inclusive social policies can help to ensure that adaptation benefits are durable and equitably shared between all urban residents. So go and read the paper. It's very nice, but you understand the importance of the point that in these kind of, what if scenarios, you can do these in digital twins and play out multiple scenarios to take care of all these kind of details about to making sure that all affected regions are equally protected and the hazard map is not just redistributed as they say, and risks are not shifted but are actually reduced in reality for all, and inequalities are definitely not exacerbated and so on. Okay, so let's leave it here.